Okay, so I thought I would post some lessons from Unit 12 that are totally optional, but definitely helpful for you as you get ready for Algebra 2 in August. Unit 12 is solving quadratics using different methods, and you'll remember in Algebra 1 we definitely solved them by factoring into two binomials and then set it equal to 0 and solve. We're going to look at three different ones. There's three different lessons. One way is if you have quadratic equations with perfect squares, you can solve them that way. It's super easy. We're also going to look at solving quadratics by completing the square, which is pretty tedious, but it's something that you will use a bit in Algebra 2. And then also the quadratic formula, which many of you are used to. Okay, so let's look at the first lesson to solve quadratic equations involving perfect squares. So what this is saying is when you isolate your x squared on one side, if your k is greater than 0, then you know you have two real number solutions. It doesn't tell you what they are, but just so you know that that's what you should have. If you isolate x squared on one side and k equals 0, then you have one real root and it's 0. If you isolate x squared on one side and k is less than 0, you're going to have no real number roots or solution because you're going to have an imaginary number, which is something that you'll go into depth in Algebra 2 with. Okay, so let's go ahead and look at some practice of what this means. So in number 1, for example, if I have m squared equals 49 over 169, this would be a great one to use the solve by using quadratic formula with perfect squares, because m squared is a perfect square and so is 49 and so is 169. So I see that my variable squared on the left is isolated and that it equals 49 over 169, which is greater than 0, so I'm going to have two solutions. Well, how do I get m by itself? So to undo something that's squared, remember we took the square root, and it's always positive or negative when you do that. The square root of something squared, that becomes m. The square root of 49 is 7, and the square root of 169 is 13. So we end up with two solutions. M equals positive or negative 7/13. And the next one, we have 15x squared equals 120. First, we have to isolate the x squared by dividing by 15. And when we do that, we get x squared equals, how many times does 15 go into 120? It goes in 8 times. Okay, so now we're going to get x by itself by taking the square root. And when we do that, we get x equals plus or minus. If you remember, 8 is not a perfect square, but there's a factor, 4 is. So if we pull that out, we get x equals positive or negative 2 square root of 2, because that's a perfect square. And we would have known that there were two solutions because when we got x squared by itself, it was equal to 8, and 8 is greater than 0. And number 3, x squared plus 16 equals 0. We'll isolate x squared by subtracting 16. When we do, we see x squared equals negative 16. When we isolate it and it's less than 0, it's no real roots, so we don't do anything because you have not learned about imaginary numbers yet. Real number roots. Okay. We're going to look at one more and then I'm going to let you do some practice. Number 4, r squared minus 22r plus 121 equals 4. So what do I see that I have here? It looks like I have a perfect square 4, but I'm hoping that I have a perfect square trinomial on this side. So let's see, the square root of r squared is r, the square root of 121 is 11. Okay, if I take and multiply and double that, I do get 22, so I'm going to put subtraction in between, so that becomes the square of the binomial equals 4. So this is great, perfect squares on both sides. To get r minus 11 by itself, we will take the square root of both sides. That'll take away the squared, and we get r minus 11 equals plus or minus 2. I'm going to add 11. And when I add 11, I get r equals 11 plus or minus 2. So 11 plus 2 is 13, and 11 minus 2 is 9. And you can always plug those into check. 13 minus 11 is 2, 2 squared is 4. 9 minus 11 is negative 2, and a negative times a negative is a positive 4. So that works also. All right, try these. I'm going to give you the answers, and then you can see if you get those answers when you do it. Okay, so 9m squared plus 1 equals 28. Your answer should be m equals positive or negative square root of 3 when you do that one. Number 6, y minus 2, y minus 2, that quantity squared equals 48. The solution should be y equals 2 plus or minus 4 times the square root of 3 when you do that one. And then try this one, 7 times the difference of 3x minus 1 squared equals 252. Your answer should be x equals 7/3 or negative 5/3. One more. And number 8 is 1/5 times x squared minus 5 over 49 equals 0. Your solution should be x equals plus or minus 5/7. Okay, I'm going to stop the video here because that's all I'm doing for lesson 1, and I'm going to start into lesson 2. Okay, so another method for solving quadratic functions is to complete the square. Of course, first you would want to see if you can factor the trinomial first, because if you can, that's so much easier than completing the square. This is pretty tedious. And also you can always check to see if it's perfect squares on both sides, and if you can use that method, that's easy too. But if you can't, you'll want to know this one as a method to use, and it says sometimes a quadratic does not factor. We can make it factorable by the process of completing the square. Before you complete the square, you should check to see if the problem is easily factorable. Remember that a quadratic equation looks like ax squared plus bx plus c equals 0. There's 6 steps. The first step is to move that constant to the other side of the equals, so you only have the quadratic and linear together. Then you're going to take half of whatever b is, which is the coefficient in front of x. You're going to square that. Then you're going to add the result to both sides of the equation. You're going to factor the left. It's going to be a perfect square trinomial. And you're going to simplify the right. And then you're going to take the square root of both equations. All right. So let's go ahead down to the practice and solving. They're the same thing. So we're going to practice by completing this square. The first one is x squared plus 16x minus 9 equals 0. So the constant term is 9. It says move it to the other side. We're going to do that by adding 9. So we get x squared plus 16x plus something. This is the part where you complete the square. Equals 9 plus something. Okay? Now it says find 1/2 of b. b is what's in front of the linear term. That's 16. Half of 16 is 8. And then you square it for step 3. When you square 8, you get 64. Step 4 says add that to both sides. That's what you're filling in. Okay? When I fill this in, I have created a perfect square trinomial. The square root of x squared is x. The square root of 64 is 8. If I take and double that, I get 16. That's what you want. You want to create a perfect square trinomial. Equals 9 plus 64 equals 73. Okay? Now we're kind of like the other part where we can square both sides to get x by itself. So to do that, we square both sides, and we get x plus 8 equals the positive or negative square root of 73. Well, I don't think 73 is a perfect square, nor does it have any perfect square factors. So to get x by itself, we subtract 8, and we get x equals -8 plus or minus the square root of 73. That's all you can do. Okay. All right, let's look at another practice one. Let's see what we have here. All right, let's do c squared plus 18c minus 175 equals 0. So I'm going to move my c term to the other side. We have a variable of c also. So I get c squared plus 18c plus something equals 175 plus something. How do we get that something? We take half of b. b is 18. We divide it by 2, we get 9. Then we square it. That is 81. We add 81 to both sides. That's step 4. We've created a perfect square trinomial. We turn it into the square of a binomial. The square root of c squared is c. The square root of 81 is 9. If I double that and multiply, I get 18. 175 plus 81. 175 plus 81. What is that? Well, you add those together. And what do you get? 256. Okay, so that's 6, 5, 256. We're going to take the square root of both sides. So we get c plus 9 equals the square root of 256. And 256 is 16, right? 16. So we have plus or minus 16. We're going to subtract 9 from both sides. When we do that, we get c equals -9 plus 16, and c equals -9 minus 16. So c equals 7, or c equals -25. Okay, I want you to try a couple on your own before we go to the next part. And we're going to get x squared plus 8x plus 16, no, sorry. X squared plus 8x minus 33 equals 0. This is number 3. Your solutions are x equals 3 or x equals -11. I want you to try this one. Y squared plus 8y equals 10. Notice your c, your 10 is already on the other side, so you're ready to complete that square. You should get y equals -4 plus or minus the square root of 26. Okay, go ahead and try these. That's the first 2 lessons. Part 2, there's a little bit more on completing the square we'll do, and then we'll go on to the quadratic formula, and I want to talk a little bit about discriminants too. So I'm going to stop it now, and we'll go on to the part 2 video.